Okay, here's part 3 of logs and exponential functions. Let's first look at just some basics of log. We're going to go back to log base 2 of 8. One thing you can do to simplify this, we already know that 2 to the third power, the answer is 3, is 8. But one thing you can do, which will help you later, is to understand some of the basic um, properties of exponents. If I go log base 2 and rewrite 8 as 2 to the third power, well, log base 2 of 2 to the third power, you could think of this as canceling out. You're taking log base 2 and you're taking the same exponent base to the third power. Your solution is going to be 3. It's really that simple. So if I gave you a log, and if I don't put a base, it's automatically base 10. And if I say of 100, well, that's basically log base 10. It's understood. You don't have to write it, but it is understood. I can make this 10 squared. What's the answer? 2. And this is just one way to think about logs. This helps me. Also, remembering these properties can help you to solve log equations and exponential equations. Some I like to call these simpler ones. 10 to the 4x minus 5 equals 10 to the x plus 2. For this one, you really don't even need to know exponential functions. You have the same base, just set those equal to each other and solve. 4x minus 5 equals x plus 2. Let's do this in our head. Subtract x, 3x, add 5, 7. X is equal to 7 over 3. And with these types of functions, you always want to substitute your value back in for x and see if it works. In this case, it will, but you always want to check. And if it doesn't work, it's called an extraneous root. So all an extraneous root is, there are roots or solutions that do not work when you plug them back in. Here's another example. 3 to the x equals 10. I need to solve for x. How do I solve for x? From the exact same principle I just showed you earlier. Remember, if I go log base 3, and watch this, 3 to the x, I'm basically going to take the log of both sides. Because on this side, what happens? Simplifies. That's going to be x. Well, on the right side, I'm going to have log base 3 of 10. I just took the log of both sides. Now you're going to have x is equal to this. Well, let's use what's called the change of base rule. Basically, to simplify this, you go log, you can put this in your calculator. Log base 10 divided by log base 3. And with this, you can use your advanced grapher to do this. Let's show you how to do log base 10 divided by log base 3 in the advanced grapher. You're going to pull up a function here. I'm going to use the calculator function over here. And you're going to have log base 10 divided by log base 3. And there's your solution, 2.095 number something. Let's cancel, get rid of that. Okay, here's another example. For this one, you want to isolate this, subtract 4. So you're going to have 10 to the 3x power equals 92. Here, take the log of both sides, log base 10. So you're going to have 3x, just kind of skip writing it out, equals log base 10 of 92. And now do the calculations here in your advanced grapher or in another calculator. And there's your 1.9638 if I round it to 4 decimal places, and then just divide by 3. And there's your final solution. On to the next part.